We are discussing now question number 12, question paper number 12. Question number 46, 100 tons of Fe2O3 containing 20% of impurities will give iron by reduction with the H2 equals to. Now when I'm talking about 100 tons having only 20% impurities, so 80 tons will be pure in this case because 20% is the impurity. So now Fe2O3, when it is allowed to react with hydrogen, it's giving me twice of Fe. So this is 160 grams of Fe2O3 is giving me twice into 56 grams of the Fe. Therefore 80 tons will be giving me 80 multiplied by 2 into 56 divided by 160. So that comes out to be 56 tons. Therefore option D. Question number 47. Equivalent weight of bivalent metal is 37.2. Molecular weight of its chloride. First of all, if it is bivalent metal, its molecular weight will be 37.2 multiplied by 2, that is 74.4. Plus, since it is we have to find its chloride, so chloride will be MCl2. There will be 2 chlorine. So 2 chlorine, that will be 71 to be added in this. So it will be 145.4. Option C. Question number 48. Rutherford's scattering formula fails for every small scattering angle because the kinetic energy of alpha particle is very larger, the gold foil is very thin, the full nuclear charge of the target atom is partially screened by its electron. The option C, because the nuclear charge is being scattered by its electron. Question number 49. Which of the having the highest E by M ratio? Now He2 plus having charge 2 and weight 4. So E by M is 2 by 4. H plus is 1 by 1. Then He plus is 1 upon 4. And D plus is nothing but 1 by 2. So this is having the highest E by M ratio. Therefore option B. In the given shell, the order of screening effect, generally screening effect is highest for S, then for P, then for D, and then F. Therefore option A. The number of electrons involved in the bond formation of N2. N2 is N triple bond N. So there are 3 bonds, so 3 2s are 6. 6 electrons will be involved. Question number 52. In which of the pair species, both these species do have the similar geometries? In case of first 2, outermost shell has 4 electrons and here it is having 6 electrons. Definitely, though the 2 is having the different type of hybridization. Over here the number of electron 5 and here it is 3. Over here again 4 and 6. The last case, this having the 6 electrons in the outermost shell and this is having the 7 electron in the outermost shell. If you look at the other geometries, over here they were having the similar type of bonding nature, but in the last case we have the different bonding nature. Over here it is having 2 minus charge, over here it is having the minus 1 charge. So in this case, if I talk about the sulfur outermost shell is having 6 electrons plus we are going to add the charge on this will be 8 divided by 4, so it will be 4. So this is sp3 hybridization, and chlorine over here is 1 by 2, so 7 plus 1, so that will be again 4 sp3 hybridization. Therefore option D. Question number 53. The amorphous solids they are supercooled liquids. Question number 54. The Gibbs-Helmholtz equation is given. Delta G we need to find, always negative. So delta G is equals to delta H minus T delta S. This will be negative only when the T delta S is positive and delta H is negative. Therefore option C, where delta H is negative and T delta S is positive. I2 is giving I2, solid is changing to gas. Delta H is given, delta S is given. We need to find a sublimation point. So we have an equation over here, that is T is equals to delta H upon delta S. Delta H is given 40. This is kilocalories, so into 10 raised to 3 divided by 80 So that comes out to be 500 Kelvin. Just subtract 273 from this. You'll get 227 degrees Celsius. Therefore, option C, which will not affect the degree of ionization, temperature, concentration, types of solvents and current. Current will definitely not affect the degree of ionization. The oxidation state of the sulfur in sodium tetrathionate. If I'll find over here Na2S4O6, sodium is 2 plus. There are 2 sodium, one is plus 1, so 2 are 2 plus. Let us assume it as X, and oxygen is minus 12, that's equals to 0. So 4X minus 10 is equals to 0. So X is equals to 2.5. Therefore, let us find out the options. It is 2, 0, 2.5 and 3.5. So option C. Which of the following is not possible at anode? When I'm talking about the anode gives us only oxidation reaction. Therefore, option A is not possible, B is not possible, they are reduction. Option C and D are possible. But if I look at the option C, the chromium 3 plus is becoming Cr2O7 2 minus, which is not possible by just dissolving in water. Therefore, option D. Question number 59. The strength in volumes of solution containing 30.36 grams per liter of the H2O2. Now, given strength is this. Generally, when we calculate the strength of H2O2, which is nothing but it's 68, its molecular weight, that is generally the equation involves the 2 molecules of H2O2. So 68 divided by 22.4, because H2O and oxygen is obtained. So this is 22.4, 68 grams will give this, multiplied by its volume. Therefore, volume is equals to 22.4 multiplied by strength divided by 68. So 22.4, strength is given is 30.36 divided by 68. That comes out to be 10 volume. Therefore, option A. Question number 60. The alkali metals. Alkali metals have only 1 electron in their outermost shell. Therefore, they can easily donate that. Therefore, act as the reducing agent. Magnesium. Magnesium is the alloy of the aluminium and magnesium. Therefore, option A. Question number 62. Aluminothermic process in which the aluminium will act like a reducing agent. Question number 63. The correct IUPAC name of the following compound is, if we'll talk about this, we need to select the long chain in this case. So the long chain is, we'll start from 1, 2, 3, 4. This is the 4 carbon over here. Then definitely the straight chain will be taking over here, also the straight chain. This is our straight chain. So if I talk about, there are 2 ethyl and 1 methyl group. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is 5,6 diethyl. Then this is 1, 2, 3, 6, 7, 8. This is 8 methyl. And the long chain double bond is present between 6 and 7. So dec 6 in. If I number in another way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be 5,6, same 5,6 diethyl. But methyl is coming at 3 position. 3 methyl dec 4 in. So this is having the lowest number. Therefore, option C. Question number 64. The toluene reacts with the excess of chlorine in presence of sunlight to give the product. When I talk about toluene, it is having CH3. When it is reacting with the chlorine, first one of the hydrogen will be substituted with chlorine. Then further chlorination will take place to give CHCl3, and finally this becomes CCl3, Cl2. This is becomes CCl3. Further hydrolysis gives us the formation of benzoic acid, which is further reacting with NaOH, we give you sodium benzoate. Therefore, option B. Question number 65. The compound is most reactive towards the electrophilic nitration. Electrophilic nitration requires the compound to be electron rich in nature. In toluene, we have a benzene ring attached to the alkyl group which will make it electron rich. Then we have option B, benzene. Option C is benzoic acid and option D is nitrobenzene. COH group and nitro both are electron withdrawing group. Therefore, option is A, as this is containing the CH3 group which is electron rich in nature. Question number 66. The atmospheric pollutant is carbon dioxide, carbon monoxide, oxygen and nitrogen. Option B, carbon monoxide. Coordination number of zinc in ZnS. Zn is a zinc blend where the alternate tetrahedral voids are being occupied. Therefore, coordination number is 4. Copper crystallizes in FCC crystal of unit cell where the age length is given A. We need to find the radius of the copper. For the FCC crystal, we have root 2A is equals to 4R. Therefore, R is equals to root 2A divided by 4. So, root 2 multiplied by 361 divided by 4. That comes out to be 127 picometer. Therefore, option B. 69. The two solution KNO3 and CH3COH are prepared separately. Molarity of both the solution is 0.1 and osmotic pressures are P1 and P2 respectively. The correct relationship between them is both the solutions are having the same concentration. But if I talk about this, KNO3 will break down further into K plus and NO3. So dissociation will occur. This kind of dissociation is not possible for the acetic acid as it is a weak acid. Therefore, definitely the osmotic pressure of the first solution will be greater than the second solution. Hence, option B. Question number 70. Which of the following concentration units are independent of temperature? Generally, the molality is depending only upon the weights and not on the volumes, and hence they are temperature independent. The product obtained at an anode when 50% H2SO4 aqueous solution is electrolyzed using the platinum electrode. When the H2SO4 is electrolyzed, we get HSO4 minus with a loss of 2 protons, and this particular HSO4 minus then migrates at the anode to give H2S2O8 and 2 electrons. Therefore, this is the product which is obtained. Option B. The Arrhenius plot intercept is equals to. The Arrhenius plot is giving the Arrhenius constant value. Therefore, option B. The term minus dC by dt in the rate equation refers to, it is showing the decrease in the concentration of the reactant with respect to time because it's a negative sign. Therefore, option A. Question number 74. The volume of the colloidal particle Vc as compared to the volume of the solute particle in the true solution. Now, when I'm talking about the colloidal solution, the particle size is nothing but between 1 to 100 nanometer. Let's assume it as 10 nanometer. Therefore, volume is nothing but 4 by 3 pi r cube. So, 4 by 3 pi 10 cube. In the case of Vs, the size is around 1 nanometer. So, 4 by 3 pi, this will be 1 cube. So, it is in the ratio of 10 raised to 3. Therefore, option A. The purest form of iron is the wrought iron, which is not a mineral of aluminium. Option A is corundum. Corundum is Al2O3. Anhydrite, definitely it's not the mineral of iron. Then diaspore is the Al2O3 H2O and bauxite is Al2O3 twice of H2O. Question number 77. When I2 dissolve in CCl4, the color obtained is, we get iodine is purple, violet in color. Therefore, option D. Which of the following iron is less ductile in nature? It is a cast iron it's called a pig iron, which contains 2 to 4.5% of the carbon, which is making it less ductile in nature. The spin-only magnetic moment we have to calculate for the Ni2 plus. Spin-only magnetic moment is equals to N into N plus 2. The N is the number of unpaired electrons. When I talk about the Ni is atomic number 28. So it's argon 3d8 4s2. When it is Ni2 plus, it will lose these 2 electrons. It will be having 3d8. If I talk about 3d8 d electrons, so 5 first and 3 will be unpaired electrons. So 2 unpaired electrons will be here. So this will be square root of 2 into 2 plus 2. So this is 4 into 2, 8. Square root of 8 is 2.84. Therefore option A. Question number 80. The specific rotation of the pure enantiomer is plus 16. Its observed rotation, if it is isolated from the reaction, with 25% of racemization and 75% of the retention. Now percentage enantiomeric axis is equals to the observed specific rotation we need to find divided by the specific rotation of the pure enantiomer into 100. Now if I talk about the specific rotation of the pure enantiomer, that is, if I talk about the 25% is racemized and 75 is retained. So 25, that means 75% is, it's almost 3/4 of the mixture which remaining retained. So 3/4 of that 16% multiplied by 100. So that comes out to be around plus 12. Therefore option is B. Question number 81. Which of the following ketone is not respond to the iodoform? Methyl isopropyl ketones. CH3, C double bond O. Isopropyl is CH, CH3, CH3. This is having the CH3 group, so definitely it will give the iodoform test. Then we have ethyl isopropyl. This will not give you the iodoform test because iodoform test is given by only those compounds having the methyl group next to the carbonyl group. Question number 82. Consider the following reaction. C2H5OH H2SO4 product. Amongst the following, which one cannot be formed as a product under any condition? Ethyl hydrogen sulfate. Here one of the hydrogen can be replaced over here. Ethylene can be obtained by this reaction because this will lose water molecule. Acetylene cannot be obtained by this method, while diethyl ether can be obtained by the continuous etherification process. Question number 83. Propane 1-ol can be prepared from the propane. 1-ol can be prepared by using the anti-Markovnikov's rule, and which is only followed under the condition of B2H6 followed by the H2O2, where the CH3CH double bond CH2 on reactions gives us the formation of the, there is addition of water molecule according to the anti-Markovnikov's rule, where the OH is added to the carbon having more number of hydrogen atom. Potassium cyanate is heated with the ammonium sulfate. The product form is, potassium cyanate is KCNO. On heating with ammonium sulfate, first it gives the ammonium cyanate, which is further on heating gives you formation of urea. Therefore option A. Which of the following reaction can produce the aniline as a main product? If you look at all the options, they have given us the nitrobenzene, which can be reduced to aniline by using a strong reducing agent like option D, zinc in concentrated HCl. Question number 86. The final product obtained by the hydrolysis of cyanides. So cyanides, when on hydrolysis, it gives R, C, double bond N. This gets the H and this gets the OH, which is tautomerized to give R, C double bond O, NH2. And finally it undergoes one more water molecule addition so as to give R, C double bond O, OH plus NH3. So product obtained is acid. Therefore option A. Question number 87. The galactose is converted into glucose in liver. 88. CF2 is a monomer of Teflon. So option D. Head to tail addition reaction is possible. That is the chain growth polymerization when monomer is. Head to tail is possible for option A. It is having a double bond over here and the para position is also active. So styrene is undergoing that electron releasing effect and therefore can give us the head to tail addition polymerization. Question number 90. They select the detergent that can be used to prepare the cosmetics. DDBS, polyethylene glycol, cetyl trimethyl ammonium chloride and LAS. Out of this, the cetyl trimethyl ammonium chloride is the cationic detergent which can be used in preparation of cosmetics because it is having the germicidal properties.